Hey, hello everyone. Thank you for joining. My name is Bhavin Shah, and I know it's top of the hour. We still have a few folks dialing in. I can see them in the attendees panel. So let's wait just a minute or two for everybody to join and have their audios connected, and we can get started. For people that have already joined and on time, thank you so much for doing that. We'll just be a minute. Actually, while we wait, let's do a couple of housekeeping items. If you, at any point during this presentation, if you have any questions, please feel free to share them or ask them using the Q&A panel that you see. And I'll keep an eye out. I'll try to keep an eye out on those questions as we go along. And if I can't, we'll basically do everything, go through all the questions that were asked in the Q&A panel at the end of the webinar. Apart from that, we will have like a resources section at the end of the presentation where you can find more information about the topic. And this presentation will be made available online. So I guess once you receive those follow-up emails, you can find links to watch it again or share it with your colleagues if they are interested in the same topic and couldn't make it today. So I think with that, let's get started, right? We are like 2 minutes into the hour. My name is Bhavin Shah. I'm a senior technical marketing manager at Portworx, which is the cloud native business unit for Pure Storage. And today we'll be talking about how do you enable your developers to deploy databases or data services on demand, basically at the click of a button. So we'll focus on one of our products in the Portworx portfolio called Portworx Data Services, and we'll spend a few minutes on some slides. So I think I have a few slides to cover, maybe 10 or 15 minutes. But once the slides are done, we'll just do demos for the remaining 30 to 40 minutes, and we'll leave some time at the end for some Q&A. Okay. If you want to find me on social media or on Twitter specifically, there are a few handles that you can reach, that you can follow if you want to reach out to me or for the broader Portworx team if you have any questions. With that, let's jump into the presentation. So let's start the discussion by talking about stateful applications and the benefits that organizations see when they are running those stateful applications on Kubernetes. So Portworx or Pure Storage did a survey last year where we worked with an independent research institute called Wakefield Research and interviewed 500 IT professionals. I think 250 of those were based in US, 250 were based in the UK. And we asked them what benefits they see. And 55% of those respondents did say that it allows Kubernetes or running stateful applications on Kubernetes allows them to scale their applications faster and allows their developers to be more efficient. And that's what we want at the end of the day, right? We want our developers to be productive so that they can contribute code, build those apps that can help increase the customer base, help improve the customer experience for your own organization. Another important statistic that came out was 54% of the respondents agree that it allows them to develop applications more quickly, and 50% said it does using stateful applications on Kubernetes does allow them to increase the security posture of their organization by leveraging the automation that comes along with it. There were a few folks, like me, more than 1/3, that did say that it helps them to reduce their IT budget. I think this is, I think, a part of the journey. So if you're just getting started, you might not see these benefits or cost reductions right away. But as you scale, as you move more and more applications onto Kubernetes, you will see that reduction in cost that comes along with it. So those were the benefits, right? But not everything is great when you're running Kubernetes. So what are, like, we also asked them, like, what are their struggles or what are some of the challenges that they face today because they are using something, because they are running stateful applications on Kubernetes. And if you look at the right side of this slide, you will see that things like capacity management, things like high availability and data mobility, things like disaster recovery and multi-cloud application orchestration are some of those challenges that organizations are facing today when they're trying to run stateful applications on Kubernetes. So we took all of this information, and basically that's what our portfolio, the Portworx portfolio, is here to help our customers with. So with Portworx, we have three main pillars that we can help organizations or customers with. we break it down into 3 different buckets. The first is accelerating data services using our Portworx Data Services product. So that's the focus of the discussion today. So instead of spending too much time on talking about Portworx Data Services on this slide, we'll cover that in the remaining of the rest of the presentation. The second piece or the core piece of our portfolio is Portworx Enterprise. It basically allows customers to run Kubernetes in production. So all the things that you saw were challenges in the previous slide are solved by Portworx Enterprise. So things like high availability, things like multi-cloud orchestration, things like cloud mobility, all of those things can be solved by using Portworx Enterprise as the Kubernetes storage layer for your Kubernetes clusters. And then the last bucket is around data protection and disaster recovery and protecting these stateful applications, even if you're running it in dev test or staging or in production. Specifically for production, organizations do have a specific SLA requirement where they need a solution that can help them meet those service level agreements by using our products like PX Backup, which is a Kubernetes backup and recovery tool, and PXDR, which is a Kubernetes native disaster recovery tool that can help you build synchronous or asynchronous relationships between your 2 Kubernetes clusters to ensure really low RPO or even 0 RPO or recovery point objective in some cases, and really low RTO or recovery time objective. And we can provide all of these different services that we spoke about on any Kubernetes or any infrastructure that you have in your own environment or that you're using inside your organization. This can be anything on-prem, so from bare metal environments to virtual machines running on, let's say, VMware vSphere, to any of the public cloud environments, including Amazon EKS, Azure, Google Cloud, IBM Cloud, Red Hat OpenShift running on these public cloud vendors. All of those Kubernetes services are supported with Portworx, and you get the same set of features and same set of experiences across all of these different infrastructure platforms and across all of these Kubernetes distributions as well. And because of this, the Portworx layer, you can basically run any application, any stateful application on top of any Kubernetes cluster and get features like high availability and replication, security and role-based access control, all of those from the Portworx layer. So that's a quick overview. We have done different monthly demos previously that cover individual topics, and we have multiple of these already planned for every month that cover different aspects of the portfolio. But without spending too much time on the portfolio slide, let's move on to the topic for today, which is talking about Portworx Data Services. Portworx Data Services allows organizations to run any database on Kubernetes. So this is really important in the times that we live today, because developers are no longer using Oracle or SQL Server database instances, a single huge deployment of these databases as the backend database of choice for building their applications. As developers are moving towards using containers or using cloud native technologies to build their new applications, they are relying on relational databases, non-relational or SQL based databases, NoSQL databases, document databases, streaming platforms, and messaging queues. All of these things are used by developers to build their applications today. So if we just use a game development company as an example, right? So when I know one such example of a game development company from the ecosystem, when they started using Kubernetes or containers to build their applications, they quickly realized that the PostgreSQL backend that they were using for relational databases running on virtual machines wasn't good enough for the performance that was expected by the application itself. So that's when they went through the journey of breaking down their application in such a way that they can follow a microservices based architecture, but also use additional database backends for different use cases as part of their applications. So they still used PostgreSQL on Kubernetes as their relational database of choice, but then they moved certain aspects of the application where they were just storing information about the users that were playing their game in MongoDB. So maybe all the artifacts that they buy inside the game are stored in MongoDB rather than having to store everything in a relational database, traditional relational database like PostgreSQL. And then they also introduced something like Kafka, which helps with the messaging piece of their application stack. So that's just one example. As modern applications are using and running these modern data services more and more in their development, and eventually those make into production environments as well. So let's say today, if you want to run these databases or data services on Kubernetes, there are different Kubernetes operators that are available to you for each of these individual data services, right? So you have, I think, 4 different Kubernetes operators for running PostgreSQL on Kubernetes. One is from Enterprise DB. I think Crunchy Data has one. And I think there's an open source one as well. So there are multiple operators and ways you can install Postgres on Kubernetes, but each of these operators have different ways in which you can deploy these databases in the first place. So figuring out how to deploy pods, how to consume the underlying storage system, how to deploy these apps in a highly available and reliable fashion. All of that is different between these different Kubernetes operators. And that's just for Postgres, right? Now let's bring in Cassandra. Like DataStax has its own operator. There are multiple operators like Sky operator available for deploying Cassandra on Kubernetes. And let's say there are like four different operators, and they have their own different way of doing the things. So if your application stack is using multiple of these database backends or data services backends to run their applications, you might be in a situation where you have to choose a specific operator. And even between these different databases or data services, you still rely on different open source projects or different vendor backends to provide you that database or data service on Kubernetes. And this is the problem that we want to solve with Portworx Data Services. Portworx Data Services provides that one single platform. It's available as a SaaS service or a software as a service model, or where all you need to do is add your Kubernetes clusters to the PDS control plane, which is something that we'll cover in the demo today, and start deploying these different databases from the catalog that's available to you today. So we have a few databases that we support at GA, which happened last month. And then we have an extensive roadmap of databases or data services that we want to onboard onto the PDS platform. So with that, let's switch to a different persona. Let's talk about what databases DBAs or database administrators care about today, right? The first thing that they care about is agility. This comes in this matters because DBAs don't want to be the bottleneck in any organization. If your development teams or developers are asking for different database backends or different database backend endpoints, you don't want to be in a situation where you ask all the developers to open tickets using ServiceNow, and then eventually somebody from the DBA team or the infrastructure team goes ahead and deploys those virtual machine-based instances or bare metal-based instances or even cloud-based instances, right? And then make sure to configure all of those according to best practices, make sure backups are enabled, and then eventually give that endpoint to a developer. This is a really slow way of doing things, and this is something that is a challenge for DBAs. The next thing that they care about is reducing costs. So if you are using one of those larger traditional relational database systems, you are paying a huge amount of money to those vendors for running as part of their licensing cost, even though they were running it on your infrastructure. So DBAs going forward, since they're going through this modernization journey, they want to make sure that whatever they choose, it can be a Kubernetes-based solution, it can be any other modern solution. They want to make sure that this modernization journey does help them to reduce the cost for their organization and avoids that vendor lock-in. So they don't want to be tied down to a specific cloud platform, specific database vendor. They want a solution that can help them move things around and change their strategy completely if a new CIO directive comes down the chain. So the cost reduction is also the name of the game. Next is performance. Anything that comes with databases it does involve performance and making sure that your applications can read and write data to it really quickly. Your customers or your end users don't have to wait even a few seconds to a minute to get data back from your website, for example, because since the switching costs are really low at this point, it doesn't take much for users to just switch platforms and choose a different vendor if they feel that they have been spending too much time on your website and they're not getting the results that they need. So delivering these high performant database backends is really important for DBAs as well. Next is modernization. So reduction of costs also comes with this modernization journey. So now there are DBAs who are listening to what the developers need. And since the developers have already started using containers and Kubernetes to build their applications, they have to make sure that they provide a modern database solution to support all the different database icons or logos that we saw in a couple of slides back. So modernization is also top of mind for them. And then at the end of the day, customer experience, right? They want to make sure that any database that they are deploying for production environments is geo-distributed, is always on, and provides that millisecond or microsecond latency, so customers can get real-time decisions and real-time interactions from their databases. So that's what DBAs care about. But let's talk about what are their challenges. What are the challenges that they face today? So starting with scaling, if you are a DBA, if you are a part of the IT team and you're running databases manually on virtual machines, on-prem or in the cloud, right? Let's just take Postgres for an example. Like, it takes a lot of time to figure out how to scale a Postgres instance, and how if you're running Postgres on Amazon EC2, for example, because scaling the database just doesn't mean that you can add more EC2 instances and your database will suddenly perform better. You also have to think about how you can shard that database so that it's actually using the resources that are available to it now, rather than just adding raw capacity under the covers. Increasing the databases also adds to this complexity. So the more databases you have as part of your organization, the more time, the more effort it takes, which leads me to the second point, right? Increasing operational complexity. So if developers do have to open up service now tickets and requests for databases, that means somebody from the DBA or the IT team has to spend time and provision those backend resources that might only be needed for a day. Like, your developer might come back and say, okay, my unit tests or integration tests worked. Now I just have to move this to a different infrastructure stack, different cluster that's running, and I need access to another database instance, maybe with the same test data, maybe not, because this is running in production. So all of this adds an additional layer of complexity when we're talking about IT teams, or we're talking about DBAs. Next is product engineering execution. Because there is so much time being spent by DBAs or IT admins on provisioning resources and maintaining infrastructure, they're not able to meet the demands of their developers. They're not able to align with the priorities that the development team has, or those line of business units have, to make sure that everybody is working towards or rowing in the same direction and moving towards a larger goal that the organization has set for us. Next is build versus buy for cloud native solutions, right? This is really important, and whenever I talk about this, I want to I like to highlight the Y Combinator talk that Jeff Bezos did back in 2008, I think, where when he was introducing AWS to a bunch of startups. And what he said was, he used an example where there were breweries in Europe in the 1800s that were also working on that were also maintaining their own power grid infrastructure to power the brewery equipment, and that's not what's going to make your beer taste better, just running your own power source or power grid. And that's the same fact I like to extrapolate, right? Just because you have the expertise in house to build a cloud native solution for building a database as a service stack, that's not what's going to make your end users get a better experience from your applications. You are going to get a better bang for buck if you spend time on innovation, rather than doing something that you can offload to a vendor and they can provide you a solution. So build versus buy is always a constant challenge, regardless of what technology stack you're going through. And then the last one is deployment time. So if just earlier this month, Pure had its conference, Pure Accelerate in LA, and I was there talking to a few folks, and they had an interesting scenario, right, where their developers were using containers and they were using Jenkins-based CI/CD pipelines to write and make sure, build and ship those container images. But then as part of each stage, they needed access to a backend database instance, and that's when the manual part, the virtual machine-based provisioning part, come into the picture. And because of this complexity, the whole thing was slowed down. The whole pipeline was slowed down, and the deployment time for these backend databases took hours to maybe a couple of days every time there was a request. Using something that's more agile, like a database as a service platform offering databases on Kubernetes, can definitely help you reduce or shrink this time from days to maybe a few minutes, right? So these are all the challenges, and that's where as part of that, Portworx decided to release something called Portworx Data Services. So Portworx Data Services, just to give you some background, was originally announced as an early access program in October of last year, so October of 2021. After working with a few customers on making sure that we are delivering the right product to the market, Portworx has now made Portworx Data Services generally available for anybody to use. It is available as a SaaS platform, a software as a service platform, where you can just create your own accounts. You can start adding clusters. You can start deploying these different databases on those Kubernetes clusters. And we support the broadest range of data services out there, right? Like to start off with, we have like 68 different databases that we support. But we have an extensive roadmap of continuously adding new and newer data services to the platform. The best part is, since this is part of the Portworx portfolio, we want to align with the run on any infrastructure platform messaging. So if you have an EKS cluster or an AKS cluster or an OpenShift cluster, or even if you're using a vanilla Kubernetes cluster, you can bring all of those different Kubernetes environments or clusters, add it to the PDS UI, and you can start provisioning these different databases on your Kubernetes cluster. So talking about a higher level feature perspective, and then after this, we have 2 more slides and we'll jump right into the demo. So we already covered the broad range of data services, right? These include things like PostgreSQL to Cassandra to Kafka and Zookeeper to RabbitMQ. All of these are supported today as part of the PDS GA, and more data services are coming down the line. DB or database as a service experience on any infrastructure. So regardless of where your Kubernetes clusters are running, in the cloud, in Amazon or Microsoft Azure, or on-prem using vanilla Kubernetes or Red Hat OpenShift, you can bring any of these environments or any of these infrastructure stacks, and we can help you get that DB as a service experience. Since we run this, we use Portworx for the storage layer or Portworx Enterprise. For each of these different databases, we can provide that built-in high availability, data protection, and security that you need for running these databases in production. Since this is a software as a service platform or portal, your admins can do some of the maintenance tasks in terms of like figuring out backup targets and backup locations, setting those backup schedules. But at the end of the day, your developers can use a UI-based platform or REST APIs to provision these different databases or data services on any Kubernetes cluster that they want. So using a self-service based platform, we give developers what they eventually need: a connection string and a set of credentials that they can use to start consuming that backend database instance. So that's what PDS delivers. And since this is a software as a service platform, we host the platform for you. So all of that infrastructure cost that you would have spent in building and maintaining your own custom infrastructure stack, all of that is offloaded to Portworx. So this is I think the pricing structure is also interesting, and we can get into more details when we talk to our sales teams, but it is on a per app or a per database deployment model. So you can get your low cost database as a service platform by just consuming PDS. So that's like from a feature perspective. Let's talk about 2 different personas, and these are personas that we'll use as part of the demonstration to follow. The first one is, what would an admin do? Like, what does an admin have to do? Basically, since this is a software as a service platform, there aren't many things that we ask administrators to do, but there are still certain things that they can control. So they can add more users to their organization or a project, and I'm using quotes for that because you can have a multi-tenant organization or a multi-project organization, and you can add users to those individual organizations or projects, and they can add their own clusters. Or if you want, admins can add clusters for your behalf, so developers don't need to like worry about adding those clusters. And we'll see how simple this is as part of the demo. Admins can also configure your backup targets and schedules. So even though developers can just enable backups using a simple checkbox, admins can still control where these backup snapshots are stored and make a few default and custom backup schedules available for the developers to select from. They can also they can also influence things like configuring custom storage options. So if you need a different file system for your database, or if you need a different replication factor than the ones that are available by default in PDS, that's something that an admin can do as well. And then configuring application configuration templates and resource sizing templates. So application configuration templates allows admins to set either dynamic or static parameters for a specific database. So for example, the default application configuration templates, the template that PD has available for, let's say, PostgreSQL, defines a database called, or deploys a database called PDS. And if this is not something that an admin likes, he can go and create a new application configuration template and leave that parameter open as a deployment time parameter. So when the developer is actually using the UI and deploying a Postgres instance, they can see this custom option available. They can enter the name of database to whatever they want it to be, and PDS will use that information to deploy that database instance. Same with resource sizing templates, right? PDS by default has a small, medium, large template available for each database instance. But if you feel that the resource requirements that you have, the minimum and maximum resource requirements that you have for each database is different from what's available by default with PDS, that's something that an admin can do and influence as well. So that's what an admin would do. What do the devs have to do to start using these databases, right? Say 4 simple steps, like you deploy your database, and that's it. You then start using your databases. If this is running in production, you enable backups for those database instances, and then you can still leverage the PDS UI to monitor your database instances. So this doesn't just give you the storage level metrics like the IOPS or throughput or latency from a storage perspective, but it also shows you the tuples in, tuples out, the number of transactions going through your database instance. All of that can be monitored using the PDS UI. So with that, let's jump into the demo section. So for demos, we will like put our admin hats on or our developer hats on and like try to mimic these personas and perform these different actions that we looked at in the previous couple of slides. What we'll do is we'll deploy a couple of different database instances. So we'll start by deploying a simple Postgres database instance, a highly available one. And then we'll try to connect to this database instance using a simple application that we have, and then deploy it on the same Kubernetes cluster. We'll generate a bunch of data, and then make sure that we can monitor our Postgres instance using the metrics tab for that DB. So that's one example. The second one is deploying Kafka with a Zookeeper backend. So Kafka, if you're running version 3.2, which is the latest one, still recommends using a Zookeeper, using Kafka with a Zookeeper for production use cases. But going forward with 3.3, I think they will remove this requirement, and you can use the native built-in craft mechanism for leader election as well. So with PDS, we know that customers either want to still continue using Zookeeper, or they want to move or start deploying these new Kafka clusters with Craft as the leader as the mechanism. We support both of these as default ways you can deploy Kafka. For this demo, we'll use a Zookeeper backend, but then again, we'll show how easy it is to switch to a different mode completely. And then we'll deploy a Kafka-based UI. We'll connect to our Kafka cluster, look at the brokers that we have deployed, maybe generate a few topics if the time permits, and produce a few messages. So with that, let me switch my screen to the PDS dashboard. So this is what the PDS dashboard looks like. If you don't have anything added, like if you don't have any databases or data services installed on any Kubernetes cluster. So let's start with a developer persona. And what we'll do is we'll deploy a couple of database instances. And while those database deployments are running in the background, we'll quickly put on our admin hats and add a new cluster and configure the storage options and application configuration templates and so on and so forth. So once you have logged in, you can get a list of all the different data services that are available to you. And you can see we have Cassandra, Kafka, PostgreSQL, RabbitMQ, and Zookeeper as the modes of deployment that are available to me. Let's just deploy a simple Postgres instance. So here, and the deployment framework or the wizard for each database remains exactly the same. Like you give it a name. So let's just say Postgres demo. We select a target cluster. So for this demo, I've already added an Amazon EKS cluster. Once I select the target cluster, it shows me a list of different namespaces that are available for me to use. So I'll select the Postgres-demo namespace that I've configured for this Postgres demo. We'll provision internal load balancers, so applications that are running on the same Kubernetes cluster can use these ELB endpoints, since this is running in Amazon, and connect to my Postgres instance immediately. In addition to all of these, we can specify application configuration templates. So I can leave it to default, or I can also select like a custom name application configuration template. where instead of using the default PDS database that's deployed for Postgres, it will generate it will deploy a database instance that has this name at the end of the day. So I'll just leave it to default for this demo, and then we can play around with the resource settings. So with resource settings, we have the small, medium, large available by default with PDS. This is something that I haven't configured yet as an admin. This is something that's available to the developer. So we can select small. I'm just using it for test app, but I still want the Postgres instance to be highly available. So let's select a 3-node Postgres cluster with 1 active and then 2 standby, or 1 primary and 2 secondary Postgres instances. And then from a storage options perspective, I do have a couple of different options available by default. I have an XFS backend with a replication factor of 2, and the volumes will be spread across my EKS clusters on a best effort basis. Or if I want to enforce that requirement that two of my Postgres pods or 2 of my Postgres persistent volumes shouldn't run on the same Kubernetes node, because that leaves me vulnerable to like node failures and suffering an outage maybe, I can also have a force spread. So let's just select best effort spread for now, and then I can select backups. So I can do a full hourly, daily, and weekly backup by default. And once I select that I want to do an hourly backup, I can select the backup targets that are available for me. So we have a backup bucket that an admin has already added for me. So I'll select the backup bucket and hit deploy. So this is all it takes to install Postgres. So as you can see, you didn't have to learn what Kubernetes operators do, what are the different parameters that you have to specify in a YAML file, or how do you even look at the different Helm charts that are available to deploy Postgres on Kubernetes. You just had to fill out a simple form, and that enables you to deploy Postgres on your Amazon EKS cluster. So while this deployment is happening, let's go and deploy a Zookeeper instance as part of the second application that we want to deploy. So we can select deploy Zookeeper, and we'll give it a name. So zk-demo. We'll deploy it on the same EKS cluster, but we'll select like a different namespace. So we have a Zookeeper-demo namespace configured for my Zookeeper instance. And application configuration template, I'll keep it to default. I'll select small. Number of nodes for Zookeeper, we don't allow you to modify this right now, because we want to, like, if you are going to use this Zookeeper as part of Kafka or as part of any other application that needs this Zookeeper backend, we want that to be a highly available instance. So by default, we deploy 3 nodes for you, but you can still change other things in terms of like the storage options available to you, or the size of the Zookeeper instance. Once you hit deploy, PDS. So the way this works is PDS will once you hit deploy on the PDS UI, it will go ahead and talk with the PDS agent that's running on your Amazon EKS cluster, and this agent will basically ask the database operators that we have running on your EKS cluster to provision custom resources. So we have a custom resource for Cassandra, Postgres, Zookeeper, all of the different databases that we support. And once that is done, once the deployment is done, so this involves configuring a backend storage class with the best practices that Portworx has for running this individual database on Kubernetes. It will go ahead and deploy stateful set instances and deploy the pods and service endpoints that are needed to connect and run this specific database instance on your Kubernetes cluster. So while Zookeeper is getting deployed, as you can see, one of my nodes is already up and running. Pod 2 is basically getting added right now. Let's go to our CLI session, and let's look at a couple of things. So this is a CLI session where a terminal session that I have access to my Amazon EKS cluster. So if I just do a kubectl get all in the Postgres-demo namespace, you can see all of the different resources that are deployed for my Postgres deployment. So here you can see we have a few Postgres pods, the number 3, because that's what the number we configured in the UI. We have load balancer endpoints for our individual pods. You can see that we are deploying Postgres as a stateful set object, and then we have cron jobs configured for our backup schedule. So the backup schedule that we choose was every hour, so that's what we have configured as part of, and that's what we have configured the cron job for as well. So that's our Postgres instance. Let me clear this out, and then let's do a kubectl get all in the Zookeeper-demo namespace. And here you can see similar concept, right? This is a custom resource. We are deploying Zookeeper as a stateful set. The number of replicas was set to 3. You can see the replica count set to 3 here. The number of pods is set to 3, and then we have service endpoints. Now, since everything is running, we can go back to the UI, and as you can see, this page has already been refreshed, and 3 nodes are up and running now. If I want to deploy a Kafka instance, which is something that we want to do, how can I connect to this Zookeeper instance, right? So each of those pods has an endpoint that I can start using, and I have a simple username and password that's configured for my Zookeeper instance. So let's just copy this endpoint and just save it in a second tab while I copy the password here. So let's go to Kafka, and we'll deploy a simple Kafka instance. So let's just call it Kafka-demo, and then same thing, right? EKS cluster, a new namespace. We'll select a different application configuration this time around. So this is something that we covered in the slides, right? The default application configuration templates do include deploying Kafka with an external Zookeeper instance, or using Craft and using something that's internal itself to the Kafka cluster. We select external Zookeeper, and because we selected a Zookeeper bucket, it gave me a couple of options. It asked me for a connection string and the password that I can use to connect to my Zookeeper instance. So we had copied the password previously, and if you remember, we had stored the Zookeeper endpoint in a different tab. So let me just copy this here and then put this as the Zookeeper connection string. We can select the size of our Kafka brokers or Kafka nodes. We'll just keep this to small because I'm not running a huge EKS cluster. It's a simple 5-node cluster that's available. And then number of Kafka brokers I want in the system is 3. So let's go ahead and hit deploy. And this basically initiates the same process. It deploys a Kafka cluster on my Amazon EKS cluster running in the Kafka-demo namespace. So while Kafka is getting deployed, let's go ahead and try to use our Postgres instance, right? So if you go back to the dashboard, you see all the different databases or data services that you have available. Let's click on the Postgres one. As you can see, we deployed a 3-node cluster. It's completely up and running. I know we had enabled backups, but you won't see any active backups till that operation is triggered for the first time. So 1 hour after this, you will see a backup show up in the backup jobs tab. But don't worry about it. I will, once we generate some data through our application, we'll take an ad hoc backup and show you how it looks like from the UI. So let's get our connection string for our Postgres application. So same thing, it gives me a virtual IP or a virtual endpoint that I can start using in my application. So going back to my CLI session, okay, I am already in the Postgres directory. This is a simple application that I use to demonstrate Postgres, where all I need to pass as environment variables for the front end is the Postgres connection string and the password to connect to my Postgres instance. So let me replace the connection string with our latest instance one, and then once that's done, we'll also get rid of the password from my previous run and update that with password for my new instance. So I hit copy password, and I can just paste it as part of this environment variable. And that's it. Like, that's all I need to do. I've updated my environment variables. I can deploy this application using a simple kubectl apply. And then we'll deploy this in the Postgres-demo namespace as well. So this deploys a service endpoint, which is a which is set to load balancer or service type equal to load balancer, and we have a deployment object for the actual pod. Now let's do a kubectl get pods in the Postgres-demo namespace, and here you can see that we have a few pods running for our front-end application that will consume our Postgres backend. Let's do a kubectl get service to fetch the service endpoint for our Postgres instance. So Kubernetes counter service was the name of our service. As you can see, we did get an endpoint from Amazon ELB, and we can navigate to this through our browser. And since this is ELB, it takes a couple of minutes for Amazon to make sure it can route the traffic from that ELB endpoint to the EKS worker node that's hosting the pod, and inside Kubernetes to the actual pod. So while all of that is happening in the background, let's go back to the PDS UI and look at how our Kafka deployment is doing. So if we go to the Kafka tab, let's see, like, okay, all three of those Kafka brokers are now available and are running in the running state. We can click on the view connection details, and it gives me the same things, like it gives me endpoints that I can start using in the Kafka UI. So let's switch to the CLI session again, and while we wait for the Postgres demo to work, we will go ahead and navigate to our Kafka directory, and we have a similar application or a demo app for you to demonstrate that demonstrate our Kafka instance. So here we do pass same set of environment variables, so we can update our connection string or our bootstrap server, which is basically any one of the servers or any one of the brokers in our cluster. Once that's done, we'll update the password with our newer instance as well. So with PDS, by default, when you deploy Kafka, we use the SASL authorization or authentication mechanism, and we use plain method. So it's basically a username and password that you provide. So username is set to PDS, and password can be copied from the PDS UI right here. So let's update the password field. And once that's done, our Kafka application is also ready to be deployed. So I can do a kubectl apply, the Kafka k8s.yaml in the Kafka -demo namespace. And as you can see, we have a deployment object and a service endpoint. We can do similar commands if we do kubectl get all in the Kafka -demo namespace. We'll see not just the things that PDS deployed for our Kafka instance, but also the Kafka UI pod that we just deployed to access our backend Kafka cluster. And similar to Postgres, we have a load balancer endpoint that we can navigate to and validate that Kafka has been deployed successfully and we can actually access it. So this is another ELB endpoint, which takes a couple of minutes. Let's just see if the Postgres endpoint is available, right? I'll come here, I'll refresh the page. Okay, my application is up and running. This is a simple application. Basically, wherever I click, it generates a Kubernetes logo. It's actually kind of fun. And it also updates the number of database records I have on the top left. So I've generated 11 logos. I can keep going, generate some IO against our Postgres backend. So when we look at the metrics, right, it shows us some different metrics than a plain chart. So now we have generated enough logos. Let's go back to the PDS UI. Let's navigate back to our Postgres instance and just click on it. And here you can click on the metrics tab, right? And in the metrics tab, you'll see the number of nodes and the status for each of those. And you will see like file system level details, so like the usage of your persistent volumes, the read and write throughput. But what's more interesting to me is if I scroll further down, I can see application level detail or like database level detail. I can get the number of transactions, the commits and rollbacks. I can get the tuples in, tuples out. If I scroll even further down, I can get the block IO as well. So here, and the one thing that I like about this is you can come here to the top of the screen and select the time frame. So you can go last hour, 2 hours, 12 hours, and 24 hours for monitoring. So even if you had some performance degradation overnight, you can still come back, log into the PDS UI, and see what went wrong and identify those bottlenecks. So if we go back, you can see that we have number of tuples. So it does show us that we tried to insert 31 new columns. So basically every Kubernetes logo generated an XY coordinate that was stored in the Postgres database. So that's showing how you can leverage the PDS UI, not just to deploy a Postgres instance, but also to monitor it on an ongoing basis. Let's see this. Let's try to see the same thing for Kafka. Let's refresh the screen here. And as you can see, the UI for Apache Kafka is also loading. So Kafka-UI is a simple open source project that I found on GitHub that you can use to connect to any Kafka cluster. And it will show you the number of online clusters that you have. It shows you the number of brokers. So we have 3 brokers right now. It can also help you simulate some data. So you can like add topics. Let's do that, right? Let's add a demo topic. And then once you have a topic, you can navigate to messages and you can produce random messages that your consumers can start consuming. So you can just add a couple of messages to your topic, and that's being stored, like that's being processed by your Kafka queue, and you can have a consumer that's picking up these messages as well. So we saw the deployment and using these applications, right? Let's go back and perform a couple of more interesting operations with the PDS UI. Now we saw, like, okay, let's start with Postgres. So with Postgres, right, I know we have an hourly backup that's going to run at the top whenever it hits 1 hour mark, but I can also create ad hoc backup jobs, right? And I can, all I need to do is come here, select my backup target, and just hit backup. It takes a full backup of my Postgres instance and stores it in the backup target, which is an S3 compatible backup repository that my administrator has already added for me. So in addition to the scheduled backups that you configure on day 0, or even day 2, like I can hit edit and I can start creating more backups. I can configure ad hoc backups as part of a PDS as well. So while an active backup is being taken, you can see that okay, that was quick enough. Our backup job did succeed. It gives you the time when it happened, the start time, the end time. It tells you where the backup snapshot is stored. It tells you that it's a full backup, not an incremental one, and it was an ad hoc backup, not a scheduled backup. And then in the top half of the screen, you will see that the last backup job was 20 seconds ago. So whenever you go to a different database endpoint, you can see when the last backup was taken, and then you can see that there are no scheduled backups right now. Let's go to Kafka and perform another interesting operation. So we started our Kafka deployment with a simple 3-node instance, right? But let's say we have a lot more topics, a lot more producers and consumers interacting with those topics in my Kafka cluster. I need to scale up my Kafka instance. Again, I don't consider myself as a Kafka expert who can like go into the Kafka CLI and perform these operations, but I can still scale my Kafka instance and add another broker. So I can increase the number of nodes from 3 to 4. And at this point, PDS sees that a new desired state has been configured for my Kafka instance, and it basically goes ahead and expands or adds another node to my Kafka cluster. So it will go from deploying to maybe a degraded state for a few seconds, and then you'll see the new node count set to 4. So while that is happening, let's switch our personas. I know we have like 12 minutes remaining. I haven't even looked at the Q&A at this point. Let's see if we have any questions while this is happening. If not, we can just put our admin hats on. Okay, I don't see any active questions. So okay, perfect. Let's put our admin hats on and see what an admin can do, right? The operations that we saw in the slide deck piece of the presentation. Let's see if we can actually do it using the PDS UI. So let's see how easy it is to add a new Kubernetes cluster. So for this, all you have to do is navigate to the PDS UI, click on this settings icon, I forgot what it's called, and just hit add deployment target. We give you a Helm command that all you have to do is run against your Kubernetes cluster, and we'll automatically deploy all the different agents and custom and operators that we need for PDS to be operational, and connect back to the PDS control plane. This is a really cool way of doing things because we are no longer asking customers to bring in their kubeconfig files, which might have some credentials that they don't want to share, or which might be time limited, because sometimes kubeconfigs have service accounts which expire at every I forgot what the interval is, but at regular intervals. So you will lose connection to your Kubernetes cluster. So what we do here is let's just copy the Helm command, navigate to our CLI session, but a different one in this case. This is another EKS cluster that we have running in US East 1. Let's just use the Helm command against that and see what happens. So we deploy all the different resources that are needed for PDS to run, or PDS to orchestrate these database deployments on your Kubernetes cluster. And once those deployments are successful, you will see that cluster being added to the PDS UI as an option. So it just takes a few seconds to a couple of minutes for the new cluster to show up. And once that's done, as you can see, our new cluster is already showing up. You can go ahead and rename the cluster so it doesn't have a weird GUID that it becomes difficult to identify when your developers are actually deploying a database instance. you want something that's more human readable versus machine readable. So you can go ahead and edit that cluster endpoint and give it a new name as well. So let's just wait for the initializing phase to be done. And once it's successfully added, we'll go ahead and update the name. So as you can see, we have the green check mark now. We can go ahead and do EKS prod cluster. Let's just give it a name. And that's it. Like now we have a couple of clusters, and that's how easy it was. Like I didn't have anything pre-configured on the EKS cluster that we just added. I just had to copy that helm command, which automatically deploys the agent and talks back to my PDS endpoint. That's for adding a new cluster. Other things that we thought we should do is like look at backup targets, right? So here we have, you can navigate to backup targets, backups, and you can add new credentials. So these are cloud account credentials. So for me, I've added my AWS account using an access key and secret key ID, and that's available as a credential. I can add new targets. So we already have one target that has been added, which we use to take that Postgres backup. Let's just add another backup job or backup target. So here, let's just call it prod bucket, because I think that's the naming convention I'm following for the newer resources. And on the back end, my S3 bucket is called bisha-pds-bucket. Now, you know, if you try to deploy an S3 bucket with that name, you won't get it because that's something that I've already taken. And then it's running in the US East 1 region. And I can just hit add, and PDS will go ahead and use my AWS credentials that I've configured and talk to the S3 endpoint and add it as a backup target that's now available to my developers. So that's how easy it is. And then the third thing I can control in terms of backups is creating custom backup policies. So here you can come and give the policy a name. So let's just do prod policy. And then this is a cool feature that I like. You can use cron expressions to define your backup schedule. So I want my backups to happen 10 p.m. every day. So once I enter that cron expression, it does tell me that, okay, what will it actually do? Like it takes a backup snapshot, or once this policy is used, it will take a backup snapshot at 10 p.m. every day. And it also allows me to specify how many full backup copies will I retain. So if I use this, it will retain 7 copies. I can bring it down to 5 if I want to, and then hit add. And now that policy will also be available for my developers to use. In addition to this, I can add some new storage options. So here I can add a new storage option. Let's just call it prod storage. We can select the type of file system, XFS or ext4. We can select a replication factor. This is to do 2, and then I can select whether I want a volume enforced policy or volume group policy enforced or not, and then I can hit add, and it adds the new storage option that will be available for my devs. Data services, and this is the interesting piece, right? So it shows me all the different databases that I have available, all the different versions that are supported by PDS. So you can see for Cassandra, we do support 3.11.13 and 3.11.12 as the 2 versions of Cassandra. For Postgres, we support 14.2. So let's just mess with Postgres, right? That's the database of choice for the day. You see that there are those small, medium, and large templates we saw as part of the dropdown. And let's just add a new one. So to add a new one, since we already have small, medium, large, let's just create an extra large or XL. For CPU, let's just do 4 to 6 CPU as the minimum and maximum, or the request and the limit. For memory, let's just do 8 gigs, and maximum can be 16 gigs. And then request from a persistent volume size, let's just do 750 gig, because that's more than the number that we already have. Make sure that you end it with something, a gig, a terabyte, a megabyte, or something like that. Once you hit add, that's the resource setting template that's now available to your developers as well. So this is how easy it is to perform these admin tasks. And then let's do application configuration templates. Let's just create a new one. So let's call it demo template, if I can spell template. And instead of defining key value pairs right here, I can make it a deployment time parameter. So I can use parameters like pg_database, and then let's create a second one, pg_user. So pg_database allows my developers to set a runtime parameter for the name of the database, and pg_user allows me to change my user from PDS, which is what is available by default, to something that you want inside your organization, right? So let's just hit add, and now this demo template will be available to our developers, for our developers to use. So now we have like basically looked at everything. Let's just look at how easy it is to add new users. If I want to add a user, all I need to do is add their email addresses here, and then do I want their permissions or role to be a user or an administrator, and that's it. Like that's how easy it is to add users to your organization. Once that's done, we can go back to our dashboard. Let's just switch our hats from the admin perspective. Let's go back to the developer persona. Let's make sure that our Kafka cluster upgraded. Let's refresh. So as you can see, a 3-node Kafka cluster is now running as a 4-node cluster since we needed more capacity. So that is good to go. Let's just look try to deploy a new Postgres instance with the new parameters that we got. So prod Postgres, just keeping with the trend. And here, in addition to the dev cluster that we have been using for most of the demo, I can also see the prod cluster that we added as the admin. I'll keep selecting dev because I know I have some namespaces configured, and I ran out of namespaces for Postgres. Let's just use the RabbitMQ demo namespace that I had created. And here I can see that my demo template is now available. So I can give it a new name. So demo Postgres as the name of my database, and then I can create a new user called demo user. I can select extra large. I'm not sure whether I have the resources, and everything up to this point in my live demo has worked. So I'll just stick to small and then select maybe 2 nodes, right? Primary and a secondary. And then I can select prod storage as my storage option, and then hit deploy. So this is how easy it is to like change things up in PDS and make sure you have different features available for your developers to leverage in a database as a service offering that deploys any of these databases on your Kubernetes clusters. So that covers the demo part of the presentation. Let me switch back to slides. I have 2 more slides, maybe 1 more, where what are the next steps? Like if you really like this, how can you get started? How can you learn more? And these are the links that you should go to. So if you go to our main landing page on portworx.com for Portworx Data Services, you can find not just this, more information, but also like different use cases, different customer testimonials, or use cases that we enable with PDS. If you are interested in learning more about how things work or how to deploy these things, personally, I've published like 3 different blogs on Postgres, Cassandra, and Kafka. So all of those are available on Portworx blogs. You can find more information on our Portworx PDS documentation, which is pds.docs.portworx.com. If you want to look at any other demos, previous monthly demos, or just some feature demos that we publish, everything goes onto our YouTube channel. And then if you really want to sign up for PDS, that's our contact sales link. Just go there, fill in your information. We'll have somebody reach out to you almost instantaneously, maybe in a day. I don't know. I don't know the SLA for our sales team, but that's all the slides and demos that we had. I know we still have a couple of minutes, and okay, I see a question. Is there documentation on what parameters that can be used during Postgres deployment? Yes. So if you look at our public documentation site, you won't find a list there. I know I was talking to one of the developers, and they are working on updating the documentation. So Rajesh, it might not be available today, but there are a bunch of parameters I know from internal documentation that are available to set during runtime, and we'll make sure that our public site gets updated too. And that was the only question. Guys, we still have a couple of minutes. If you want, feel free to put more questions in the chat. If not, before everybody starts hanging up, I would like to thank everybody for their time today. I know taking an hour out of a busy day might be something too much to ask, but thank you for joining me. If you have any questions, you can reach out to me through social media, send me emails. You will receive follow-up emails that you can respond to. Thank you so much for your time. This was a fun session for me to plan and conduct. So I had a lot of fun. I hope you did too. Thank you so much. Okay, demo was really good. Okay, thanks, Rajesh. I appreciate that. Well, I think with that, I'll close the broadcast. So I think everybody will get kicked out. Thank you so much again, and hope you have a great rest of the day.